The 2025 F/F² Death Degrees F1/2 missile is one of the most talked about next-generation strategic weapon systems being discussed by defense analysts this year, and it represents a major shift in how modern missile technology is being designed, deployed, and integrated into broader military networks. Rather than being just a single projectile, the F/F² Death Degrees F1/2 is described as part of a complete strike ecosystem, combining long-range precision, advanced guidance, and survivability features that reflect the evolving nature of modern warfare. What makes the F/F² Death Degrees F1/2 missile stand out immediately is its reported emphasis on speed and maneuverability. In today's defense environment, traditional ballistic paths are becoming easier to predict and intercept. Systems like F/F² Death Degrees F1/2 are believed to counter this by using advanced flight profiles that include variable trajectories and mid-course adjustments. This makes interception significantly more difficult compared to older generation missiles that followed more predictable arcs. The idea is not just to be fast, but to be unpredictable in the air. Another key aspect is propulsion. While exact technical specifications remain classified, defense observers suggest that the 2025 F/F² Death Degrees F1/2 may use a hybrid propulsion approach. Early-stage boost could rely on solid fuel for rapid acceleration, while later phases might involve more advanced propulsion management to sustain speed and extend range. This kind of flexibility allows the missile to cover long distances while retaining the ability to change its flight behavior depending on mission requirements. Range is also a major talking point. The F/F² Death Degrees F1/2 missile is often described as a long-range platform, potentially capable of reaching targets far beyond regional theaters. This shifts its role from a purely tactical weapon to something with strategic influence. Missiles in this class are not just battlefield tools, they are political and deterrence instruments. Their existence alone can alter how nations plan their defenses and alliances. Guidance technology is where modern missiles truly separate themselves from older designs, and the F/F² Death Degrees F1/2 is no exception. Analysts believe it uses a multi-layered guidance system. This likely combines inertial navigation with satellite updates and possibly terrain or scene matching technology during the final phase. By not relying on a single guidance source, the missile can maintain accuracy even in contested environments where signals may be jammed or disrupted. Accuracy matters because modern doctrine increasingly emphasizes precision over sheer explosive power. Instead of relying solely on large warheads, newer systems aim to strike critical points with minimal deviation. The F/F² Death Degrees F1/2 missile reportedly follows this philosophy, focusing on precise targeting of infrastructure, hardened sites, or strategic facilities. This reduces the need for multiple launches and can achieve objectives with fewer resources. Survivability is another defining trait. Modern air defense systems are more advanced than ever, featuring layered detection using radar, infrared sensors, and networked command systems. To deal with this, the F/F² Death Degrees F1/2 missile is believed to incorporate stealth-oriented design elements. This might include radar-absorbing materials, a shape that minimizes radar reflection, and flight paths that exploit gaps in coverage. The goal is to reduce detection time and shrink the window defenders have to respond. Electronic countermeasures could also play a role. Some reports suggest the missile may carry systems designed to confuse or overwhelm defensive sensors during its approach. These could include decoy signatures or signal disruption techniques. By adding complexity to the defender's task, the missile increases its probability of reaching the intended target. Mobility of launch platforms is equally important. Fixed launch sites are increasingly vulnerable to surveillance and preemptive strikes. The F/F² Death Degrees F1/2 missile is therefore associated with mobile launch systems. These may include road mobile launchers or other transportable platforms, allowing forces to relocate frequently and remain unpredictable. Mobility enhances survivability not just for the missile, but for the entire operational unit. Integration into a broader command network is another modern feature. Missiles like Eth-squared Death Degrees Eth-1/2 are not isolated weapons, they are nodes in a digital battlefield. Data from satellites, drones, ground sensors, and other sources can feed into targeting decisions. This allows for more dynamic mission planning and the possibility of retargeting under certain conditions. Such networked capability reflects how warfare is increasingly information-driven. From a design perspective, the Eth-squared Death Degrees Eth-1/2 missile also symbolizes a generational update. Materials science has advanced, enabling lighter structures that can withstand extreme heat and stress during high-speed flight. Better onboard computers allow for faster processing and more complex decision-making during flight. These improvements may not be as visible as speed or range, but they are essential to overall performance. Strategically, the Eth_Eth tilde Eth-squared Death Eth-micro Eth-1/2 Eth tilde of the Eth-squared Death Degrees Eth-1/2 missile fits into a global pattern. Many countries are investing in advanced missile technologies, particularly those capable of evading existing defense shields. This creates a cycle of action and reaction. As offensive systems improve, defensive systems must adapt, leading to new interceptors, sensors, and early warning networks. The Eth-squared Death Degrees Eth-1/2 missile is one piece of this larger technological competition. There is also a deterrence dimension. Long-range precision missiles contribute to what strategists call credible deterrence. The idea is that potential adversaries must assume such systems can reach critical assets, which can discourage aggression. Even without being used, the presence of these missiles influences diplomatic calculations and military planning. Training and doctrine evolve alongside hardware. Operating a system like the Eth-squared Death Degrees Eth-1/2 missile requires specialized crews, secure communication lines, and strict command procedures. Safety protocols are critical, as is coordination with other branches of the armed forces. Modern missile units often train in simulated digital environments that replicate complex combat scenarios, ensuring readiness without actual launches. Another angle to consider is cost and production. Advanced missiles are expensive due to high-tech components and precision manufacturing. However, their effectiveness can offset numbers. A smaller inventory of highly capable missiles may achieve results that once required larger arsenals. This efficiency is part of why countries pursue such advanced designs despite the financial burden. Internationally, systems like Eth-squared Death Degrees Eth-1/2 often draw attention in arms control discussions. As missile capabilities expand, questions arise about stability, escalation, and the balance of power. Diplomatic channels sometimes address deployment, testing transparency, or limitations, though these processes are complex and politically sensitive. Public perception also plays a role. News of new missile systems often captures media attention, sometimes leading to speculation that outpaces confirmed facts. It's important to separate verified information from rumor. Much about the Eth-squared Death Degrees Eth-1/2 missile remains officially undisclosed. An open-source analysis relies on patterns, past developments, and observed trends in technology. From a technological standpoint, the Eth-squared Death Degrees Eth-1/2 missile highlights how aerospace engineering, computing, materials science, and electronics converge in modern defense systems. It is not just a weapon but a showcase of industrial and scientific capability. Developing such systems requires years of research, testing, and refinement. Looking ahead, future upgrades could focus on even smarter guidance, improved resistance to electronic warfare, and further reductions in detectability. As countermeasures evolve, so too will offensive technologies. The 2025 Eth-squared Death Degrees Eth-1/2 missile is therefore likely not an endpoint, but a step in an ongoing progression. In summary, the Eth-squared Death Degrees Eth-1/2 missile represents a blend of speed, precision, survivability, and integration that defines the current generation of advanced missile systems. Its reported capabilities suggest a focus on overcoming modern defenses while maintaining strategic reach. Beyond the technical aspects, it influences military planning, deterrence strategies, and international security discussions. Whether viewed as a technological achievement or a symbol of shifting global dynamics, the 2025 F² Death Degrees F1/2 missile clearly reflects the direction in which advanced military systems are heading.